Good morning. So we were in the next module today. We are going to start. We just finished module 4 in the last class. That was about pedestrian safety and vehicle ergonomics. So particularly last period, we have learned aspects of vehicle ergonomics. So and particularly, we were looking at what is vehicle packaging, that is vehicle occupant packaging. So we looked at some of the important definitions that are related to vehicle packaging and vehicle reference system and key vehicle dimensions and reference points associated with occupant packaging. Then what are the sequence and development of procedure in vehicle packaging. So this is all something that we were looking at in the last period, and that ends at module 4. And module 5 is more of again looking at in detail vehicle safety systems, right? So I'm going to share my board to look at vehicle safety systems in the morning this lecture, and afternoon A2 slot also we will have, and we'll try to complete maximum possible by afternoon. In case we require, we may go for one more period, right? And thereafter, we have 2 more modules in our course, that is focusing on injury mechanisms and injury criteria, and then one dedicated module for introduction to dummy history, dummies that are going in for crashworthiness evaluation. So this is all remaining to complete our course. And we were also revised in the last class what are the important key dates that are coming in this week to end our semester smoothly. Okay, so let me share my board. Let me share my presentation. So in the last class, essentially, we were looking at this vehicle occupant packaging, those 3 important aspects. And today's class, we will get into module 5, vehicle safety systems. So these are the lecture points as per your syllabus content. I have just marked that we are going to look at one after the other. So we may start with what is that understanding of survival space requirement of a vehicle in case of a crashworthiness to realize. And what are various restraint systems used in automobiles? Those are essentially safety belts, head restraint systems, airbags, and use of energy absorbing system. That's what are called crumble zones in front as well as in the rear. Then impact protection from steering controls. There are collapsible steering mechanism. There are some steering controls that could have protection against impact that may fall on category of active safety system as well. That you may have a system that would prevent accidents to happen. And then design of seats for safety. There are types of seats. The importance of bumper. There are some criteria that we have to learn. Damageability criteria in bumper design. And types of safety glass and their requirements. So the glasses glare, the night vision, especially to see, and then to avoid sunlight straight away falling inside the occupant space. That may have some vulnerable ultraviolet infrared waves that come in, and so they may have some safety glasses involved in that. And then rearward field of vision automobiles, that are different types of rear view mirrors and their assessment, how are they done. You'll have to look at, and warning devices like hinges and latches, and external projections, door locks and retention systems, rear, front, side under end protection devices, and so on. So it is basically looking at vehicle safety systems in an organized manner. So for that, let's look at our automotive safety can be defined or can be looked at like this. Automobile safety is a study and the practice of design, construction, equipment, and regulations to minimize the occurrence and consequence of automotive crash. So minimize the occurrence of automotive crash is what is called an active safety, and minimum consequence of automotive crash is what is ensured by system called passive safety. So if you look at these two class of safety systems in vehicle, you may also see in textbooks or in literature that active safety system is to avoid accidents occurrence. So avoid the occurrence of crash, whereas the passive safety protects occupants in the event of crash. So that is how you can look at it. These active safety systems are many. So we will see one on each and every one of them and their basic definitions and have an insight. Some of them we have already learned in our vehicle dynamics course, that is anti-lock brake system. So we had dedicated lectures, and we looked at free body diagram of rolling tires, and then the braking force and moments that are involved in free body diagram that's equivalent to that was the input that are supposed to go for your ABS system and so on that we have seen. And there are different types of ABS architecture and so on. But what is this ABS? Why is it called an active safety system? So ABS allows wheels on motor vehicle to maintain tractive contact with the road surface based on driver inputs while braking. This prevents the wheels from locking up. This is very important. So ABS main function is it's preventing wheels locking up or ceasing rotations, and avoids uncontrolled skidding. So if vehicles are locking up, then only you have a phenomena called skidding. So then if locking up is avoided, then uncontrolled skidding can be avoided. This automated system works on the principle of threshold of braking and cadence braking. So you have to get a maximum braking efficiency. At the same time, we should prevent sudden locking of wheels. So we have seen that the sequence of locking of wheels, in case locking cannot be prevented completely, the front wheel locking can be permitted compared to that of rear wheel locking. Rear wheel locking is very, very vulnerable because it's locked, then there will be drifting from rear, and that would create a kind of oversteered effect, and your vehicle is in high speed and suddenly you brake and wheels lock, and you are definitely going to lose the exercising of your steering. That's all something that in physics of vehicle dynamics, especially on braking performance part, we have learned. So this ABS is an important active safety system, is because that ABS gets its 100% and the maximum efficiency of braking. That means the vehicle can stop without any skidding, with the complete control of steering in the shortest distance required in case of any sudden intrusion of objects onto the road, and you have to jam on the brakes, and that would safely brake if vehicle is employed with this anti-lock brake system. So that's one of the active safety system, and that to prevent occurrence of crash accident. That's why it is active system. Then electronic stability control. So electronic stability control also acronym sometime used in many of the vehicle brands that can also account for ABS as well as for traction control system and so on. So electronic stability control system is especially for different operating state of your wheels on different roads. So you have to have a complete control of your vehicle for that. So ESC system improves vehicle stability by detecting or reducing loss of traction. So you may have loss of traction when you have suddenly the road surface changes from dry surface to greasy surface or water surface. Suddenly you see there would be loss of traction because of film formation between the surface of the tire and the road surface. And we also have learned about what is hydroplaning. So the hydroplaning is something complete lifting of your tire from the road surface because of filling of fuel, wedge of fuel, not fuel, fluid that comes inside the wheel and the road surface. So in such kind of condition, you have hydraulic lift and force, and that would create loss of contact of tire with the road, and that should be prevented. So that is what is can be taken accounted by electronic stability control. The system prevents crashes by reducing the danger of vehicle skidding or driver losing control as a result of oversteering. So that oversteer effect all can be reduced. The system becomes active when a driver loses control of his or her car. So what will happen if you have electronic stability control? Even a driver is unable to take an action, that would be automatically happening in such cases. And adaptive cruise control. So this is another interesting active safety system. Is an intelligent form of cruise control that slows down the speeds up automatically to maintain a safe distance from vehicles ahead. So we have listened to one of the project and vehicle dynamics course on adaptive cruise control. Batch has done wonderful presentation of the project. Everyone would have gone through the lecture. So we have this cruise control so that in traffic flow, the vehicle can adjust itself to the environment, looking at an ahead vehicle or rear vehicle. Accordingly, the speed can be adjusted so that the safe distance could be maintained. That's what is ACC. And then tire pressure monitoring system. The tire pressure is very, very important to be always maintained. That should be on a rated pressure recommended for the wheels. In case that the tire pressure is not appropriate, you would have again problems in your vehicle. So this tire pressure monitoring system is an electronic system designed to monitor pressure inside the pneumatic tires at various types of vehicles. Report real-time tire pressure information to the driver on the vehicle, either via a cage or a pictogram display. A simple low pressure warning light. So you would have there are signboards on the panel in front of the driver. You can have warning light indicating there is low pressure in your tire. So you may have to take a necessary step, stop your vehicle, exchange your tire, and so on. You can also have a different way of doing it readily available for the driver, what is the pressure in the vehicle tires. And then lane departure warning. Lane departure warning is again important. Unless the warning is not there, there can be an unexpected accidents. So that minimizes many accident scenarios. So lane departure system is a mechanism designed to warn a driver when the vehicle begins to move out of its lane on freeways and RTL roads. These systems are designed to minimize accidents by addressing causes of collision such as driver error, distraction, and drowsiness. So these are all some of the causes that we have seen on the driver can take the vehicle to accident scenario. So the lane departure warning system give an alerting system to prevent such kind of accidents. Then night vision system is another safety system that extend the protection. Perception that extend the perception of the driver beyond the limited reach of headlights through the use of thermographic cameras. There are thermographic cameras, their display can be there very far away. If something is there, it can be immediately seen. Infrared lights, head-up displays, and other technologies to prevent accidents. So night vision system is very important system. We also have this blind spot detection is another safety system that spots are areas, blind spots are the areas outside the vehicle that the driver is unable to see. This can be caused by the window, pillars, headrest, back seat passenger, other objects. So that's what would happen when you are taking a turn. Sometime it's a wider road and you take a turn, your front A pillar may hide the vision of the vehicle that's coming ahead, especially in curves. So headrest and backseat passengers also can hide your rear view through rear mirror. When you see your headrest position is can be obstructing your view of rear view. So such kind of thing, the driver cannot be able to locate this outside environment of the vehicle. That's called the blind spots during that time. So this blind spot detection system is a vehicle-based sensor device that detects other vehicles located to the driver's side and at the rear. In case the driver unable to notice it, this system would take care of it. And then driver monitoring. So if you look at this all active safety system, if you see that are all what are the developments in a vehicle, as a vehicle to be a product which is taking your vehicle which is manual operated to an automated vehicle. So the autonomous of vehicle system is what is with the different levels that are classified. So you see these kind of active safety system development in vehicle, upgrade your vehicle. That's also to be noted. And then driver monitoring system. So driver monitoring system is what the safety system uses infrared sensors to monitor driver alertiveness. So you are driving, there's someone is always looking, watching you without your knowledge that what's happening to you. Are you driving with full conscious or not? Or sometimes you are drowsing, not feeling well, or under high fatigue. So there can be a drowsiness. So that alertiveness of driver is being monitored by a system called driver monitoring system. Specifically, a driver monitoring system includes closed circuit camera, placed on the steering column that is capable of eye tracking via infrared light emitting diodes. So these all information you should be knowing it. That may be for your quizzes, right? So the detectors. So this light emitting diode is what is the detectors. So if the driver is not paying attention to the road ahead and collision is imminent, the system flashes lights and warning sounds for the driver. In case he is not alertiveness or drowsy, then such kind of warning can be given by driver monitoring system. Then road sign recognition. The road sign recognition notifies and warns the driver to enforce restrictions on the road. So though we were looking at all these road signs and its signification, one of the lectures, and especially on pedestrian safety, when we are looking at, and the road signs can be overlooked by the driver. In such cases, the road sign readers on the vehicle would be there. Then according to the road sign, if the driver is taking step or not can be understood, and then it can be corrected. So such kind of road sign recognition warning system also is there to alert the driver. So automatic emergency braking. So automatic emergency braking is not ABS. It's something that vehicle takes its control to stop the vehicle. The system slows the vehicle and potentially reduces collision severity in unavoidable situation. If the driver's braking is not enough to avoid a collision, autonomous emergency braking applies maximum brake pressure to reduce the speed and impact of collision. So the judgment of the driver sometimes may go wrong, and then you may not be able to appropriately give the necessary braking action. Though he does it, it may be delayed response or may not be sufficient brake pressure. In such cases, this automatic emergency braking would take an action to bring back the vehicle on control. So, or to avoid the unwanted accident scenario. So these are all something very important active safety systems that go in vehicle. And if you look at further, so then the other one is what is called the passive safety system. That's anytime you look at car safety features, there are many images that are there on the internet that you can look at. One such image I have taken, nice image that brings in a wholesome of passive safety system in first hand that everyone looks at in a vehicle, right? So these are essentially for to minimize the accident severity. These passive system cannot prevent the accident, like an active safety system that we have looked at so far. But these safety systems present in your vehicle can minimize the severity and improve the crashworthiness of the vehicle in a severe crashing of vehicle. So that's what you could see here clearly. There are this pink color in the front as well as in the rear, along with the bumper zone. This is what is called front crumple zone and rear crumple zones. So these are essentially the elements which are going to absorb the maximum kinetic energy that are there during the collision, and they would dissipate them successively. And so that the energy, rebound energy, residual energy that is getting transferred to the safety cell, that is where the occupant and drivers are present, would be minimum. And further, those energy can be nicely managed by means of other restraint systems like airbag and rear seat belts and front seat belts and side impact bars. And so on. Side impact bars like a crumble zone, this would take more energy during side impact, and it would bend and then take more energy. Here it is not crumbling, whereas here it's a crumble zone. There is and the seat belt. So seat belts, airbag, and crumble zone are the key passive safety system present in any of the vehicle, and they have become mandated nowadays. So if you have to look at them in detail, airbag, acronym as AB. So automotive airbags consist of a flexible fabric bag or a cushion designed to inflate rapidly during a collision. So inflate rapidly during the collision in no time, in few milliseconds, that would be acting, deploying. Its function is cushion its occupants during the crash when they hit objects inside, such as the steering wheel or a window, that windscreen. Modern vehicles comprise multiple airbags modules in different side and frontal locations of the passenger seating positions, which offer maximum protection during the collision. So it is looking at an airbag as an explosion. Actually, it is a chemical reaction that makes that has been triggered and then by an electronic switch there, and that is what is going to create a chemical reaction that would produce nitrogen gas, and that would be inflating your airbag back. And that is what is the mechanism. We will see that in detail in the next lecture, working principle of these restraint systems as a topic. And now let's go ahead with just having an idea of what is this airbag system. So their prompting that the deployment of the airbag should be so quick, rapid enough, so that it would protect the occupant before the occupant getting hit with the interior of the vehicle. So see that already, you know, the crash events in few milliseconds, say 100 milliseconds, it gets over. So the time the impact starts, the role of airbag and your seat belt should be in action, and they would be so quick enough in few milliseconds they are ready, so that the entire event would not be prevented, but the occupants can be saved, prevented from having interaction or hit with the trims of the interior of the vehicle. That's a purpose of airbag and seat belt as well. So seat belts are safety belts installed on the passenger seat of a vehicle to secure the occupant against harmful movement that may result due to collision, jerk, and sudden braking, and so on, or sudden hit from the rear by the other vehicle. You suddenly stop. So this is all going to be there. At that time, it would make the driver or occupant intact with the seat. And that will also assist the right position of the occupant, so that the airbag deployment can cover the occupant. If you are not with the seat belt and you would have in some direction going and the airbag deploying, and that all will not function and do the necessary safety measure for the driver. So that's what is to be carefully noted. Then occupant sensing system. So occupant sensing system is another passive safety system. So it is a system of sensors that detect who is sitting in the passenger seat occupant sensing system eliminate the need for an on-off switch for airbag in most cases because they are sophisticated technology to identify whether to adult or a child is in the seat. The sensor assembly is installed on the bottom cushion of the passenger seat and is used to suppress or enable the passenger's airbag based on the classification of occupants. So you can have different occupant by age, by gender, by size. So everybody has to have the compatibility with your restraint system. So this occupant sensing system helps that to have an appropriate deployment of these restraint systems according to the occupants. And then whiplash protection. That's very, very important thing. Even at slow speed, this is going to create a severe injury to the drivers and occupant that is associated with your neck spinal. So this is happening normally when a vehicle is hit by the rear and then your snapping of your head would be so rapid, then you get your neck injury. So that's what is called a whiplash, and its protection is what is head restraint system all about. So is a whips equipped, whips is saying that whiplash protection system equipped seat is entire backrest is designed to protect the front occupant's neck in case of rear impact. Whips utilizes a specially designed hinge mount that attaches a backrest to the seat bottom, which has a predetermined rate of rearward movement in the event of certain type of rear impacts. The seat back also has a series of springs that allows the cushion to move slightly backward on impact, thereby creating the body within the seat. This combined with the high mounted head restraint to limit the whipping motion of head that often occurs during rear end impact. So whiplash is associated with the rear end impact. The seat design and head restraint system design is such that their rest support to the head should be appropriate, so that the snapping or the whipping motion of our neck during rear impact can be prevented or safely handled. And then child safety systems. Child safety system, the automatic door lock and so on already present. So the child safety systems are specifically designed seats that protect children from injury or death during collision. Generally, these seats are installed based on end user requirement. So you have high-end vehicle where a child can be put in that seat and then can be restrained. They are safe in their cage. So it's like that. Then pedestrian safety systems. So look at here, you can have a vehicle passive system that can protect in the event of collision the pedestrian who is going to get in contact with the vehicle. So there are some exterior airbag system for that. Maybe here, let's read. The system prevents vehicles from colliding with the pedestrians by sensing the situation and provides guidance to make a decision. In most of the advanced vehicles, the system automatically decreases vehicle speed to avoid a collision with the pedestrian. So it is a kind of active safety system that is marked in passive safety system. If it is able to make that judgment and instruct vehicle speed to avoid collision. But if collision happens, there are exterior airbag system that pedestrian under the hit would be fallen on the front dashboard and then maybe thrown up on the roof and so on. And such cases, the cushioning effect from exterior can save the pedestrian injury level. So that's all something in upcoming vehicle safety measures, current safety measures in high-end vehicles that we could see. Right, and these are something as far as safety is concerned. And when you say the survival space requirement in specific, if you look at as per our syllabus content, you say that is nothing but passenger safety cell. So when you say this passenger safety cell, that is all because of this body in white and its design. So look at the cage inside the cabin here. So these are various geometrical terminology that go in body in white. So body in white is not an entire vehicle, assembled vehicle. It is that one where it is on that the entire thing is assembled. So you see here clearly we have different zones and the different names, and they all should be always be knowing this. So you see the bumper, and then there are two projection here. That's is called a crash box or crumble zone here, you can say. And then a long member. Long member is that one is this, and you have here where the engine is going to be mounted. And there's something called the sill. Sill is something this horizontal base member. So this is sill like that. And then A pillar. A pillar is where your windscreen is framed. So this portion is what is A pillar. And then B pillar is what is there, your door latches are there made. So this is B pillar, the middle of your thing. And you see that continued, and then there is kind of a ring. So you see there is a frame that goes around this, So that vertical portion is what is called B pillar. And C pillar is what is from the mid, whatever is there, rear goes, or you see the rear windscreen taken there. So this portion is what is C pillar. So, you know, in sedan class vehicle, you see that you have A pillar, B pillar, C pillar. There are heavy vehicle like you have this boot space bigger. You can also sit there in big vehicle like in such vehicles. We have also D pillars, right? And you see on this side you have interior definition like firewall. So the firewall is such that it should take more energy, but it should not collapse too much. So this has to have its shape retained, then only this cabin shape will be there. So this firewall should be prevented penetration of engine, other tough components in front of the vehicle, space here. And then you see here there is something called tunnels. Tunnels are these members. So here you can see those are tunnels along the longitudinal dimensions there, and you see this white space is what is floor. Floor carpets are there to isolate vibrations that we put for comfort. And again, you see here, since it's a rear view, you can see like a crash box. That's again kind of a crumbling effect during the collision. That would take away maximum energy. And these cross members here are on the floor. You could see that's again for the integrity of this survivor space. So if you have such a body in white, first is manufactured, then this is being used to assemble other components such as the engine, chassis, and exterior, interior, and so on. So then you would be able to have your passenger safety cell ensured. So the passenger compartment here, what you realize in this, has to resist being penetrated. So nothing should penetrate during the collision. Has to hold together so that occupants are not thrown out. So from this, occupant should not go out. That's how this is designed. And can't make entire car crumble zone because the people inside will crumble. So crumbling should be this portion completely can crumble, or this portion here can crumble. But this cabin cavity has to be integrated. And designed with a rigid, strong frame enclosing the occupants. So you see that there, yeah, rigid, strong frames. And crumble zones in the front and rear are also present, right? So what does mean by crumble zone? Areas of vehicle that are designed to deform and crumble, and a collision is called the crumble zones. They absorb some of the energy or maximum energy that you would say that as we are seeing during the impact, preventing it from being transmitted to the occupant. So it has to take a maximum possible energy, and the energy transferred inside should be minimum, and that could be further managed by passive safety system. And then again, there is another picture that I have taken, which is giving you more and more details of your safety aspects. The one readily we have seen crumble zones, airbags, and side seat belts and side airbags. And you have here so detailed locations of various safety systems. Especially here, you could see child safety seat compatible with the safety belt. So you see this separately, child can be protected here. And the crumble zones are, this all can be not only a crash box. You don't say that as a crash box is a crumble zone. That's called a crash box. But crumble zone is this entire region. So this entire region. So it has got a very rigid mass like an engine mass and other motors and so on. But they would have a displacement. At the same time, they would not go and hit the firewall and get into this. And the rest of the components would act as more elastic in nature and would not in elastic, elastoplastic in nature, you can say, so that they fail axial mode and the crumbling happens and maximum energy is being taken away. So here, this is why it's more detailed is because the front impact sensors, there are impact sensors that are there that would indicate immediately the alertness of all systems that are present in this. And then you see again here laminated windscreen. The windscreen is laminated so that your glare, night glare won't be there. And then you have side airbags, diagnostic module here, high strength steel safety cage surrounding passenger. So you see here, this body in white has got more, it's a long vehicle, sedan class, luxury car, and you have this kind of frames crossing each other and integrated along with your A pillar, B pillar, and C pillar. You have secured safety cage. That is what is called a safety cell or survival space inside possible. And then you have a head restraint system. See, there is nice seating that support behind the head. Yesterday class we have looked at the ergonomic aspects. So you see that since your hatch point would be very low and you would have the longitudinal distance measured from accelerator heel point to this would be more. And the other hand, SUVs would be other way that we have seen. And then rear crumble zone and see front and rear lap shoulder seat belts. So when you look at seat belts, they are nice. So the 3-point seat belts and 4-point seat belt, 5-point, like many number of attachment it comes. Basic airbag is, sorry, seat belts are of 3-point seat belts. We'll look at the working principle of this restraint system in the next class. Then you see here, airbag and igniter shown deployed. So here airbag is deployed. That's what is appearing here. So that's all because of bursting of chemical reaction that go in to create nitrogen gas. So the sensor, there is a gas generator, and that gas get filled in airbag bag. So that is how this all working. And then see padded knee bolster. So you have here also again pads in case of accident to prevent the knee injuries and so on. So like that, there are many passive safety systems that could be witnessed, especially with reference to their location in a vehicle in this picture, right? And then vehicle restraint system in particular, if you look at, no, we have to study this crumple zone, seat belts, head restraint system, again airbag, side airbag, and side curtain airbags. So side curtain airbags are this. This is side curtain airbags. Side airbags are this, and front airbags are these are front airbags. So that can deploy from the steering wheel, or it can deploy from the panel board top. So you have both. So this would have bigger volume to cover. And the seat belt and the airbag should go together to work. And the work of seat belt is to hold the driver occupant along the seat. And then the deployment of airbag could cover that entire occupant and can be prevented. And this picture here, you could see the yellow in color that represent the zones which has to crumble and take maximum possible kinetic energy. And the one without an yellow color is what is the safety cell or survival space during the crash event. Seat belts and airbags. So this is all something that called the vehicle restraint system that we are going to study in detail. And crumble zone, if you look at, I have here in this slides many information. The details of crumble mechanisms here generally would be of this kind of various topographies, geometries. So you see that it can be of different shapes like that, which all essentially to undergo mechanism of collapsing in a axial manner or collapsing. In this case, you see there are tubular sections here, so the tubes get collapsed. So that's not an axial manner. So it is a circular tube and it collapsed as if it's become puppet like that. So it would initiate here, and this all would become like this 1, 2, 3 like that. Entire thing. This would all absorb, and this will not have any elastic property after that. And once the energy is absorbed, get dissipated at plastic deformation, and then you have to remove them, and that protects that absorbs maximum energy and protect the rest of the vehicle, which is easier for reconstruction of your vehicle. So after the accident scenario, you would not cost much for you to get back your vehicle on working condition. At the same time, as the maximum energy is absorbed, the occupant also is being protected. It acts as a passive safety system. And in this hand, you can see some of the real-time simulation of your crumble zones in frontal collision and then corresponding acceleration level at a point in the cabin variations. The test as well as on the simulation that go hand in hand, almost mapping only with some phase angle differences. Otherwise, they are almost same. And you see here the energy balance chart, the total kinetic energy here has been absorbed and it is going. And the dotted line, it's the one that shows that the energy dissipation accounted here. Now, there is no consideration that is possible in the event of collision if you say that they are crumble zone. But here to show that energy management, the energy dissipated is what are this here, and that shows back again this total deformation energy. So this is all total deformation energy. That is not stored energy as the spring energy that we say always. So that was the question in our module 3 also. How can you consider the linear spring for this model? The linear spring, but very much aware that the spring would collapse and the elasticity is lost. So there is no residual, there is no strain energy that can be stored. So the spring get deformed and the energy is stored. That's the basic principle of linear spring. But if the energy dissipated, then that is going to stay as it is. So the length is not going to vary there after more. There is no unloading process. In such cases, you can still have a spring mass as a representation for to have simplified crash model that we have seen. And then what is the main important characteristic of the crumble zones? So offer stiffness under normal conditions, but crumble in crash. So this won't just, you can't just make it crushing it. You can't just push it. So, during a crash, what does that exchange is? Impulsive force. Impulsive force is defined as a high magnitude force in the shorter duration. So such a high magnitude force only can make this stiff condition crumble structure. These structures to crumble. So that's what is here. That is to offer stiffness under normal condition, but to crumble in a crash. It vary depending on the size and weight of the vehicle. Strike a balance between too much, too little impact resistance. Simple designs, frames, segments built in blend in certain areas of collapse onto themselves. Advanced design use variety of metal and other materials engineering to absorb as much as possible kinetic energy. So somewhere we read some of the energy is absorbed by crumble. No, it's maximum energy that has to be absorbed and dissipated from the air. High performance cars cars use 5 materials, honeycomb structure design as a crumble zone structure. So I'm happy that one of our batch students are working on crumble zone simulation, where they have been experimenting with the tubular section with the induced axial cuts around the circumference, or induced flange kind of grooves along the length, and so on. There are 4 different axial energy absorbing system. They are studying it. And that is also available in our channel. Please go through a visit of their presentation. So this is all something that we have to talk about. The crumble zone, and a basic requirement of crumble zone is the energy absorbing system. It is basically of the vehicle crash. And then restraint systems used in automobiles. So when we continue, we have another one on hand is seat belts. So there are 3-point seat belts. So this point is fixed, and where this belt will go over here, and the belt will be pulled from here. There is, and then there is a buckle on the other side should be buckle. And there is tension in this would be there, and we will see this working principle in the afternoon class. But however, let's look at an important information along this seat belts, when it was started and so on. So the seat belt was invented by Charlie L. Strath in 1935. It has been used as a must for automobiles today. Seat belts are the most representative and major vehicle protection devices in the history of automotive passive safety systems research and development. In the process of automobile traffic accidents, it mainly uses the occupant restraint to absorb and buffer most of the energy generated by collision, so as to avoid occupant hit into a cockpit, or the happening of second collision. That means what? If you are restrained, then you don't hit again and again. So the second collision can be avoided as much as possible to reduce occupant injury and economic loss. So that's what is the main purpose. According to National Highway Traffic Safety Administration estimates, the use of seat belts reduces 45% of fatal injuries and 50% moderate to severe injuries to the car front occupants, while 60% to 68% for the light truck occupants. So the invention of seat belts have made huge safety measures and lives possible. So that's why it's very important that we start, before start our vehicle, we should wear the seat belt. Though we know that we go in very slow speed and so on, it is mandate that we should have our seat belts work. And then another restraint system is head restraint system. That's what is to prevent whiplash. So you see here there are head restraint rating that is there. So that's called an x-axis back set in centimeter and distance from the top of the head in centimeters. So you have there are different colors here, the zones 1, 2, 3, and 4. Zone 1 is that minus 6 centimeter till plus 6 centimeter from the top of the head surface. And then the back set can go up to 6 or 7 centimeters. So if your back set, the surface falls on this, that is a safe zone. That's a safe zone. So there can be allowable tolerance till the safe zone 2, but 3 and 4 should be avoided. 4, of course, zone 4 should be avoided. That means your headrest should not have the contact below this. That means there is there's no headrest. So something this is called geometric head restraint rating that go in. So static geometric evaluation are based on measurements of height and backset that are made from the mannequin. So this is mannequin representing an average size adult male. To be rated at least marginal, the top of the restraint should be no lower than the center of gravity of the head and no further than 11 centimeters behind the head. So center of gravity of the head is here. So it is not no lower than 10 centimeters. So till 10 centimeter, right? And then till 11 centimeters. So that means it is taking zone 1, 2, and 3 also. So the danger is only zone 4. Otherwise, the head restraint geometric evaluation is poor. Higher, and see why this zone is there is because that mannequin here represent an average size adult male, but you have drivers of different types. So in such cases, the zones are going to account them always to be falling in a safe zone 1, 2, or at the worst zone 3. That is what is this. And this is measured in a static geometric evaluation. You sit and then the headrest location to be designed accordingly. Higher the headrest provides the protection for even taller occupants, and closer the headrest can reduce the time the head is unsupported in a rear crash. As acceptable geometric rating implies, a head restraint no further than 8 centimeter below the top of the head and no further than 9 centimeter behind it. So that's what is representing 1 and 2 zones. Good geometric implies the head restraints no further than 6 centimeter below the top of the head and no further than 7 centimeter behind it. That's green zone 1. So this is called a good zone. This is called moderate or acceptable. Zone 3 is limiting, and zone 4 to be avoided. Right. So this is how you look at the placement of head restraint system in your vehicle. And then another interesting passive system is the airbags, and you see here the airbags is on the deployment process. It is not completely deployed. It is in the process of deployed, and the high-speed cameras capturing this during the test, or it's a virtual test, and this is made. So the aspects, interesting aspects of airbags were first invented by Swedish people. The first patent of American airbag was made in the 1950s, and some factories started to develop airbags in 1970s. So the patent was made in 1950s. Almost 2 decades, it is taken to commercialize that, incorporating the vehicle. In 1972, General Motors took the lead in large-scale airbag field test. After the 1980s, more cars equipped with airbag technology tended to improve. In the 1990s, the number of airbag installation increased rapidly, and there are many new technology products. The first airbag to prevent side impact, see side impact airbags, curtain airbags that we have seen, was first developed by General Motors in the year 1996. In the 21st century, the airbag has become a very common and a vital safety device in automobiles, and today it's going to be mandatory aspect of a vehicle. And this airbags is an auxiliary occupant restraint system which works with the seat belt to prevent occupant from being hurt by the car's interior trims. It mainly includes the controller. So if you look at an airbag, it has got a controller, a sensor, and gas generator and airbag bag. That's what is the sensor, and then there is a controller, then gas generator and an airbag. There's an explosion that takes place, the chemical reaction that is going to provide a nitrogen gas, and that is what is happening in gas generator, and that fills the airbag. After the controller receives the signal, it is immediately begins to analyze and judge whether to open the bag. It will immediately to send the ignition instruction if it is necessary. After receiving the ignition command, generator quickly generate enough gas to air-filled gas until the airbags fully open now, and then contact with the soft passenger airbag, preventing the occurrence of 2 collisions of the car parts, reducing the traffic accidents caused by the occupant injuries and the economic losses. So this is all the advantage of the airbag. And then this again, if you look at it, has got a sensor, controller, gas generator, and airbag. So you see here, sensor, one of the most important component on a car airbag, used to capture signals such as speed and acceleration when car collides and send the signals to the controller. So the sensor, dedicated sensor for airbag would sense what is the speed during the collision and the acceleration level that would be sent to the controller. And the controller used to receive and analyze the speed and acceleration signal of the vehicle and determine whether to send an ignition signal according to the analysis. In case of collision, the more accurate judgment of the controller and can accurately control the ignition time and some and more the airbag can be opened correctly to maximize the protection of the occupant. So even the time that we read is enormous. So quick enough, it is in few milliseconds, maybe within 5 to 10 milliseconds, this entire reactions would take place and gas would be generated. So the gas generator, when the car collides, the gas generator quickly generates enough gas and immediately inflates the airbag. The gas cannot be harmful to the human body. No pollution to the air and gas temperature not too high to avoid burning of the human body. At the same time, it requires high stability and high reliability. So what is that kind of reaction in the gas that we'll see in the afternoon class? And airbag bag, when airbag expands, the explosive force is large and the temperature is high, which requires the airbag bag at high strength and good elasticity. Thermal performance is strong. At the same time, with high stability, aging resistance, small volume after folding, and can quickly expand, and the airbag cannot scratch the human face. See, so much. It's not a simple bag that you see in vacuum cleaner. That's a cloth bag. So you see, this bag is so much different properties that has to have to meet all of this. The important thing is it cannot scratch the face of the human. Among them, the gas generator is the main component. So out of these four, the gas generator is the main component of the airbag system. Its role is to provide sufficient gas with explosive speed in a very short period of time. That's what they're saying. So few milliseconds, within 10 milliseconds also, the entire deployment will happen, so that the coverage of occupant by airbag is ensured. When the occupant is in contact with the airbag folds up the occupant's head to avoid touching other parts and reduce the injury. So this is how the airbag function. But still, that working of airbags we will see in detail in afternoon class. And at present, the typical products are active pop-up hold hood and pedestrian protection airbags. That's what I was telling. You also have pedestrian protection airbags. The active pop-up cover is triggered by warning sensor installed in the bumper and other locations. When the vehicle collides, the hood is popped by gunpowder or spring to increase the cushioning space to reduce the head or upper limb injury for the pedestrian. The technology has been applied in Jaguar XJ and Citroen C6 and other models. You can see them in YouTube videos. The installation of outer airbag and car's head also appeared in Ford, Fiat, Stilo, and Toyota and other models. The hood airbag developed in Ford in 2007 was, see, it's not a now new concept, 2007 was mounted above the bumper and up to the hood surface. After that, Toyota launched a 360-degree airbag protection system between the bumper and the engine cover, between the engine cover and front windshield, fender and rear view mirror were installed 5 airbags to the front, all wrapped, thereby enhancing the pedestrian traction effect as well. So airbag for outside occupants also there, outside the car's pedestrian also is there in our vehicle restraint system safeties. This is where I would like to stop this lecture, and then we will see continue with the vehicle safety system and understanding more detail working principle of seat belts and airbags and some other important aspect like head restraint system and so on in the next period. And then maybe possibly we will complete. Otherwise, we will continue with one more lecture to complete this module. So with that note, I'd stop lecturing. If you have any doubts or anything to discuss, you can. Otherwise, I'll end the lecture. Anything?